Welcome to Nardar Academy. In this video, we are going to discuss about general equation of circles and straight lines in the complex plane, reflection points with respect to a straight line, inverse points with respect to a circle, and finally about collinear or concyclic points. Okay. See, let's start with equation of circle. In coordinate geometry, you have studied equation of circle as x minus a the whole square plus y minus b the whole square equal to r square, isn't it? Where that a comma b represents the center and r denotes the radius. In the same way, in complex plane, we represent the circle in the form z bar plus alpha bar z plus alpha z bar plus beta equal to 0. See, this z bar is nothing but our what? X square plus y square. Okay, these are all our x term, y term and constant. So the same way we are writing it here, right? This is the equation of a circle in complex plane. Here this beta is a real number and alpha bar minus beta must be positive. So for this circle, the center is given by minus alpha and radius is r square equal to alpha bar minus beta, right? And similarly, for equation of straight line, in coordinate geometry, equation of straight line is given by y equal to mx plus c, no? So it's a first degree equation. In the same way, here the straight line equation is given by alpha bar z plus alpha z bar plus beta equal to 0. Okay, here alpha is not equal to 0 and beta is a real number. So these are the general equations for circle and straight line. Here, see, here it is z bar is coming, no? Here that term is not here because for straight line it must be a what? First degree equation. Okay, and look at this alphas here. If this is alpha bar, its conjugate must be here. Here also in the straight line also. Straight line is nothing but without this term, it represents a straight line. If this term is present, it represents a circle. That's all. So this condition is important. See, if this is alpha bar, this should be its conjugate. Here also the same thing is followed. So these are the general equations of circles and straight line in the complex plane. Next one is we have a concept of reflection points. Okay, see, I am having a line L. This is my line L and I have 2 points P and Q here. Okay, see, now you join this PQ. This is a line segment PQ, no? For this line segment, if this L forms a perpendicular bisector, then this P and Q are called what? Reflection points of this line L. That is, you have 2 points P and Q. You are dividing this by the line L. If this line L, this line divides this PQ into two equal segments, that is PO equal to OQ, and this is perpendicular. So perpendicular bisector means these 2 points are called what? Reflection points. Okay, reflection points of the line. This is the definition. But for doing problems, if you are given with a line and if you want to check whether Z1 and Z2, two given points are reflection points, the condition to be satisfied is alpha bar Z1 plus alpha Z2 bar plus beta equal to 0. Okay, so for doing problems, this is the condition to be satisfied for 2 points Z1, Z2 to be reflection points for a given line, given straight line. Okay, and similarly we have a concept for circle. Okay, see, we have 2 points P and Q and we have a circle with center at O and radius R units. This is a circle with center at O and radius R units. Now you join OPQ. Suppose OP into OQ equal to R square, then this P and Q are called inverse points. Or what do you say? P and Q are called inverse points with respect to this particular circle. This is the definition. So for doing problems, 2 points Z1 and Z2 are inverse points with respect to this circle. This is the general equation of the circle, no? This circle, if and only if this condition is satisfied, that is Z1 Z2 bar plus alpha bar Z1 plus alpha Z2 bar plus beta equal to 0. One more concept we are going to see. See, if you are given with 4 distinct points Z1, Z2, Z3 and Z4, the condition for checking whether they are concyclic or collinear, the condition is argument amplitude. I have explained in the previous video. I have given the link in the description. If you want, you go through that video. Okay, argument of this cross ratio. We call this as cross ratio. That is how I am writing is, write the 4 points. Numerator will be Z1 minus Z3 into Z2 minus Z4. Denominator is Z1 minus Z4 into Z2 minus Z3. So this argument must be either 0 or pi. Okay, otherwise the value of this cross ratio is purely a real number. Okay, either argument is in terms of angle, the argument either should be what, 0 or pi, or else what can you say, this cross ratio value is purely a real number. If it happens, what do you say, the four numbers, the 4 points are either what, concyclic, either they form a circle or they all lie in the same straight line. Okay, right. Let's see some problems are based on these concepts. This is the first problem. Find the inverse point of alpha. Okay, this is alpha with respect to mod z equal to 1. So let's take z1 equal to alpha and z2 be its inverse point. Now let us write the circle equation in the standard form. Mod z equal to 1 means it's a circle with center at origin and radius equal to 1 unit. Let's square on both sides. So it will be z bar equal to 1. Now, 2 points are said to be inverse points if this condition is satisfied. Z1 Z2 bar plus alpha bar Z1 plus alpha Z2 bar plus beta equal to 0. For this given circle, alpha, beta are all 0. Only Z bar is there. So, what's the condition for this circle? Z1 Z2 bar equal to 1. So, this must be satisfied. Okay. Now, let's substitute Z1 equal to alpha and Z2 equal to Z2 itself. So, alpha Z2 bar equal to 1. So Z2 bar equal to 1 by alpha, or Z2 equal to what? 1 by alpha bar. So the inverse point of alpha with respect to this unit circle is 1 by alpha bar. Okay. Next problem. Find the inverse point of minus I with respect to the circle 2z bar plus I minus 1z minus I plus 1 into z bar equal to 0. Here you see, whenever you have a circle equation, you just verify whether this coefficient of z and coefficient of z bar are conjugates. Here it is I minus 1, no. So its conjugate is what? Minus I minus 1. Yes, it is there. Okay, just you have a check. Okay, right. Now for z1 equal to minus I, let z2 be the inverse point with respect to this circle. So what is the condition to be satisfied? 2z1 z2 bar plus I minus 1 z1 minus I plus 1 z2 bar equal to 0. Let's substitute z1 equal to minus I and z2 equal to z2 itself. So minus 2I z2 bar plus I minus 1 into minus I plus 1 into z2 bar equal to 0. So take z2 bar outside. So minus 2I minus I minus 1 plus here it will be minus I square plus I equal to 0. So z2 bar into minus 3I minus 1 plus here I square is what? Minus 1. So minus of minus will be plus 1 plus I equal to 0. So z2 bar equal to minus 1 minus I by minus 1 minus 3I. So it's equal to 1 plus I by 1 plus 3I. So whenever you have I in the denominator, you have to eliminate it by multiplying and dividing by its conjugate. It's 1 plus 3I, no. So multiply and divide by 1 minus 3I. So 1 plus 3I into 1 minus 3I by here what? A plus IB into A minus IB. So it will be A square plus B square. So it is 1 square plus 3 square. So it will be 10 in the denominator. For the numerator, it will be 1 plus I minus 3I minus 3I square. So it will be 1 minus 2I plus 3 in the numerator. Okay. So Z2 bar equal to 4 minus 2I. Cancel 2 throughout. So what you get? 2 minus I by 5. This is Z2 bar. But Z2 equal to what? 2 plus I by 5. Okay. Right. Then the next one is find the equation of the circle passing through the points 1I and 1 plus I. Okay. For finding the equation of the circle passing through 4 points. That is, we need 4 points. Okay. One more point I am going to take, that I am going to take it as Z as an arbitrary point on the circle formed by these 3 points. So for condition for forming a circle is the cross ratio of the 4 points is a real number. Whenever you want to prove something is a real number, you have to take the number is equal to its conjugate. Okay, no real part, only real part will be there, no imaginary part. So the number will be equal to its conjugate in case of real numbers. So the cross ratio equal to its conjugate. Here I have taken Z1 equal to Z and Z2. 1 plus I are given, no, that I am taking as Z2, Z3, Z4. So write the cross ratio. Z minus I into 1 minus 1 plus I divided by Z minus 1 plus I into 1 minus I in the left hand side. For the right hand side, you have to write the same thing, conjugate. Okay, the whole conjugate can be split up to individual term in the next step. Then again, this individual term, no, you can apply for conjugate individually. So Z bar minus I conjugate will be plus I. So here minus I conjugate, no, so it is plus I. So like that I have written. Then you cross multiply the terms. You cross multiply and then you simplify. So very big steps are here. So after simplification, what do I get? See, I am getting it as z is here, this is what I am getting after simplification, minus z bar into 1 plus I plus z plus I z bar equal to 0. Don't leave the equation as it is. Okay, what I told you, whenever you have a circle equation, the coefficient of z and z bar must be conjugates. Okay, so here you are having 1 plus I, no, that minus 1 plus I throughout you divide. So what I have z bar plus 1 by 1 plus I z plus I by 1 plus I z bar equal to 0. When you have I in the denominator, multiply and divide by conjugate. So 1 minus I by 1 plus I, the whole 1 plus I into 1 minus I. Here it is I by 1 plus I into 1 minus I. So by taking conjugate and multiplying, we are getting the final answer like this. Now let us check. Here it is 1 minus I by 2 and here it's conjugate 1 plus I by 2. So whatever result you have got is correct. Okay. So this is the required equation of the circle passing through the given 3 points. Okay. That's all. Thank you.